All right, now we're going to actually, so now you know how to use the law of sines and the law of cosines. So now let's put them into action and actually use them to solve application problems. These are actually used in the real world quite regularly. So we have a ship that's going from St. Thomas to St. Croix, and it's 40 miles away from each other. It maintained a constant speed of 23 miles per hour, but it encountered heavy crosswinds and strong currents, and they found that after 1 hour, the yacht was off course by 41 degrees. So it was off course, so instead of going in this direction, it was off course by 41 degrees. If it was going 23 miles an hour, after 1 hour, it's gone 23 miles off course. So we're trying to figure out how far is the yacht from St. Croix. There's my yacht. So I'm looking for solving for this right here. All right, so we have, let's see, we've got a side, angle, side, triangle. So when I have that, that's a law of cosines. So let's figure that out. So I know this, we'll call that x. So x squared is going to equal 23 squared plus 40 squared minus 2 times 23 times 40 times the cosine of 41 degrees. So we end up getting that x is about 27.2 miles away. So this is 27.2 miles. How much time has been added to their trip because of this? Well, now they've gone 23 miles in the wrong direction, and they're going to have to go 27.2 miles in this direction. So they have to go 23 plus 27.2. They need to go 50.2 miles. The trip was supposed to be 40 miles. So how many miles did that add? Well, they now have to go 50.2 miles. The trip was originally supposed to be 40 miles, so they've added 10.2 miles to their trip. If they're going at a speed of 23 miles per hour, that would be, you can figure that out, so 10.2 miles. We want to figure out the time, so that means the hour needs to be on the top and the miles on the bottom. So 1 hour, they go 23 miles. That way I'm just left with the hour for time. So that ends up adding a total of 10.2 over 23 hours, which is about 0.44 hours. Now, if you were going to put that in terms of minutes, okay, we've got 0.44 hours. Changing it to minutes, we know there's 60 minutes in 1 hour. That way those cancel, and I'm just left with minutes as my unit. So that's 26.6 minutes that it added to the trip. All right, so let's look at another application. Joe needs to determine the height of a tree before cutting it down. All right, I'm going to draw my tree. It's terrible. All right, he walked away, and the angle of elevation from one point when he looked up was 40 degrees. Then he walked 20 feet further and looked at the angle of elevation again and got 30 degrees. So we need to figure out what the height of this tree is. Okay, when I look at this, I see a few things. So I see a right triangle as the green one, but I don't have enough information to be able to do right triangle trig. But if I can figure out, let's just call this guy x. If I can figure out what x is, then I could do right triangle trig because this is the side opposite, this is the hypotenuse, so the sine of 40 degrees equals the opposite over the hypotenuse. So what I need to do, because I can use SOHCAHTOA for this green triangle, I need to figure out what x is. All right, So let's just look at this red triangle here. I know that I've got an angle here is 30. I know this length here is 20. I can figure out this other angle because if you think about it, if you've got a right triangle, put it next to another right triangle, you've got a straight line. So the angle for a straight line is 180 degrees. You could also think about the unit circle. A straight line has a 180 degree angle. So if part of this straight line here is 40 degrees, that means that this has to be 140 degrees. Now we know for the angles of a triangle, they have to add up to 180. So 140 plus 30 plus 10 is what gives us that 180. All right, so now I have a triangle I can actually deal with. So I can solve for this side x. So here you can see I have an angle, a side, and an angle, or you can look at it as I have an angle, 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 side. Okay, so this means that I can use the law of sines to solve for x. All right, so I'm going to set this up. So the sine of that 10-degree angle divided by its opposite side equals, now I want to solve for x, which is here. So the opposite angle is 30 degrees. So the sine of 30 degrees divided by x. So now I can go through and solve for x. X times the sine of 10 degrees divided by 20 equals the sine of 30 degrees. So I get x times the sine of 10 degrees equals 20 times the sine of 30 degrees. Divide everything by the sine of 10. And I get that x is 57.6. So now I know that this right here is 57.6. So now I have a right triangle where I know the angle, I know the hypotenuse, and now I just have to solve for the side. So the sine of 40 degrees equals the height divided by the hypotenuse. Multiply both sides by 57.6. And I get that the height of that tree is about 37 feet. Okay, so let's look at another application problem. So this tells me I have a Little League diamond, which is set up like this, 60 feet, which means that all of these angles are going to be 90 degrees. Okay, if I draw a straight line between second base and home plate, so this angle is going to be 45, this angle here is going to be 45. From home plate to the pitching mound is 46 feet. First question wants me to know what this length is from the pitching mound to first base. So let's kind of draw this triangle out a little bit separately. So I've got this part here. I don't know if this is going to be a 90-degree angle here. I don't think it's going to be, but we can't assume. So I know this is 46. I know this length here is 60, and I know that this angle here is 45. I'm trying to find this. So I've got a side, an angle, and a side, which tells me I can use the law of cosines. So x squared equals the other side squareds and added together, minus 2 times the length of each side times the cosine of the corresponding angle. So when you do that, you'll end up getting that it's 42.58 feet. Now if I want to figure out how far away the pitching rubber is from second base, so now I'm trying to figure out this length right here. So let's draw this big triangle. Okay, so this is going to be a right triangle between second base, first place, and home plate, and then all the way back up. Each of these is 60. I can figure out the length from home plate up to second base, and then I can use that to figure out how far away the rubber is from that. So let's first figure out how far the distance between home plate and second base. Since this is a right triangle, I can do a squared plus b squared equals c squared. So that ends up giving me 7,200 equals c squared. So c is about 84.85. So I know that this length from here to here is 84.85. The length from here to the pitching mound is 46 or 42.58. No, 46 feet, sorry. 46 feet. So from here to here is 46 feet. I'm looking at how far away is this to second base. Well, clearly if you add 46 plus whatever this is, we should get 84.5. So if I take 46 plus, we'll call it y, the length of the pitching mound, to second base, that has to add up to 84.85 feet. So we end up getting 38.85 feet. Okay, last question. If a pitcher faces home plate, through what angle does he need to turn to face first base? All right, so we're basically trying to figure out what this angle is right here. We can use the law of cosines again to figure that out, because I know if I pull this triangle, I had that triangle written right here. So if I look at that triangle, I've got, wow, I drew that really bad. Okay. I've got 46 and I've got 60. And I found out that the length from the pitching mound to first base, we solved in letter A to be 42.58. I know this is 45 degrees, so I can solve this using the law of cosines. So we've got, see, I'm solving for this angle, so that means this is the side I'm going to write first. So 60 squared equals 46 squared plus 42.58 squared minus 2 times 46 times 42.58 times the cosine of theta. I'll let you go through, solve, and you'll end up getting that theta is about 85.2 degrees. Okay, let's do another application problem. We've got 2 more left. All right, so we've got a fire station, and there are two of them, and they are half a mile apart. 1 mile is 5,280, so that means half a mile is going to be 2,640 when I divide that by 2. There is a fire at point C, and we want to figure out which one's going to end up being closer to it. They've told us that angle ABC, which means whenever you see 3 letters written together, it's the middle letter. That's the angle they're talking about. So we're talking about angle B here. This one, the middle letter is A, so that's angle A here. So we know that information. They want us to know, without doing computations, how we know that station A is closer to fire station B. If I were to set up this triangle, this would be little b, this would be little a. So remember that based on the bigger the angle, the bigger the side's going to be. So the smaller the angle, the smaller the side. Notice that angle A is bigger than angle B, which means that side A is going to be bigger than side B. Side A is the distance from B to C, so from station B to the fire. So that is going to be a bigger distance here than it is here. So again, opposite the smaller angles is going to give you the smaller side. All right, so now it wants us to calculate to the nearest tenth how much closer station A is to station B. So that means I need to figure out what these lengths are to be able to figure out how much closer it is. All right, we have a side angle side triangle, which tells us we can do the law of sines. So in order to do the law of sines, I need this last angle. So I know that 180 degrees minus 47 minus 41 leaves us with 92 degrees. So I know that angle C is 92 degrees. So I can figure out the remaining sides by using the law of sines. So the sine of angle C divided by side C equals the sine of angle A divided by side A. I'm going to let you guys go through, solve that for A, and you'll end up getting 1,931.95 feet. For B, we'll do the same thing. So the sine of angle C over the length of C equals the sine of angle B over side B. I'll let you go and do that algebra. You end up getting that side B is 1,733.05 feet. So to see how much closer station is from station B, we will take 1931.95, subtract 1733.05, and we end up getting that it is 198.90 feet closer. Okay, we have one last problem to do, and we're going to do a bearing problem. All right, so when it comes to bearings, I'm just going to kind of review it really fast. You've got your North Pole and you've got your South Pole, okay? And then our East and our West. Whenever we're talking about bearings, you're always going to have the North or the South written first. So if I had North 20 degrees East, that would be starting from your North Pole, and you're going 20 degrees from the North Pole in the eastern direction. If I gave you North 50 degrees West, again starting from the North Pole and going 50 degrees in the western position. So when we're first setting this problem up, if I've got an airplane, I've got my north, south, east, west. All right, so south 29 degrees is going to be starting from the South Pole and going 29 degrees in the western direction. Okay, then it changed course. So I draw another little bearing here. And at this point, it changed course and it went again south, west, 52 degrees. And it flew for a little bit longer, and then it landed at an airport. And this wants us to know how far away those two airports are. Okay, holy moly. I'm going to draw a separate triangle over here of this scenario, just because I feel like sometimes seeing it like this and not with all the other junk in it makes it a little bit simpler to deal with. So I can figure out what the lengths are here. I can do that because it did tell me how long it flew for and how many miles per hour it was flying. So we can first figure out, let's figure out the 20 minutes. So I'm wanting to figure out what that length is going to be. It flew, so we want to figure it out, length is going to be miles, not in terms of time. So for 20 minutes, it flew at a speed of 420 miles per hour. Well, my issue is minutes isn't going to cancel out with hours. So what I need to do is I need to find something that's equal to an hour in terms of minutes. Well, how many minutes are in an hour? 60. So it flew 420 miles in 60 minutes because 60 minutes is equivalent to 1 hour. So now when I do that, those will cancel out. 20 times 420 divided by 60 gives you 140 miles. So in 20 minutes, it flew 140 miles. So from the first airport, before it changed its bounds or its direction, it flew 140 miles. And then it flew in this direction to the second airport in 2 hours and 20 minutes. Well, to figure out that distance, each hour it flies 420 miles an hour. So 2 hours times 420. And then it went for another 20 minutes, which I just found was 140 miles. So that means it went 980. Okay, So again, all I did is I did my conversions for figuring out if this is the pace that it was going, 420 miles per hour. I changed it to miles per minute so that when I just divided those went away, and I was able to figure out 140 miles in 20 minutes. So that gave me that first part, and then it flew this direction to the second airport for 2 hours and 20 minutes. Well, for every hour it flies 420 miles, and then I have this extra 20 minutes, which I just found was 140 miles, so there's that length. Sweet, okay, I've got two sides, but I can't do Pythagorean theorem here because this is not a right triangle. Womp, womp, womp. So I'm gonna see if I can figure out an angle. And I think doing this middle angle is going to be what's going to be the easiest. So let's look at what I know. Well, I know this part here is going to be 90 degrees because that's a right angle. All right. I also know, do you guys see this is another right angle right here? So I know this part is 52 degrees, which means that's what's left is going to be 38 degrees. 38 plus 52 is 90. Now this one's the one that's a little weird. I'm going to write my 29 a little bit prettier, just so you can see right where that is at. All right, so that doesn't quite help us with figuring out what this angle is going to be. Because once I get this angle plus this angle plus this angle, I have this whole thing. So I need to figure out this angle here. Well, I do know I could draw a right triangle here. That's 29. That's a right angle, so that would leave this to being 61. This whole thing here creates a right angle, so that would leave this to being 29 degrees. So this angle is going to be 38 plus 90 plus 29 degrees, which ends up giving us 157 degrees. And this is what I'm solving for, is that length. Once I have that, now I've got a side angle, side triangle, which tells me I can use the law of cosines to figure out that missing side. So setting that up, we've got that side, because that's what I'm solving for, equals the other two sides squared, added together, minus 2 times each of those sides, times the cosine of that angle, which ends up giving me about 1,110.22 miles. And that's it.